All right, guys. As we tackle this new stuff with confidence intervals and things get a little crazy, let's kind of review what we talked about on the last video. When we interpret a confidence level, don't forget we have this template. I typed the template out for you guys here, and we just take the information out of this piece. So they are 90% confident. So we're 90% confident that the interval from 0.229 to 0.291 captures the true. Here you got to watch the wording because it comes from here. So it's not just the true proportion this time, it's the true difference in the proportion of teens and adults. Whoops. Adults who say yes to using social networking sites. It's going to be a lot more than that now, but remember that study is an old one. So, to using social networking sites. And so the idea here is when we're interpreting a confidence interval, we are 90% confident that in 90% of all possible samples of the same size, the confidence interval would capture the true difference in proportion of teens of teens and adults who would say yes to using social networking sites. So just remember, most of this is the same. You just got to kind of learn to interpret these little pieces here. Okay. All right. So based on the confidence interval, is there convincing evidence that the proportion of teens who would say yes is higher than the proportion of adults who would say yes? So let's just look at the confidence interval. So we have this confidence interval here, and it goes from 0.22 approximately to 0.29, right? That's our confidence interval, like that. And we know that 90% of the time, the answer is going to fall in between there. So 90% of the time, the answer is going to fall between there. That means that if there was no difference, let's just say there's no difference. If there's no difference, then teens minus adults would equal 0, right? So anything above 0 would be teens would say yes at a higher proportion. And anything below 0 would be that means adults say yes. Well, our answer is 90% of the time is going to be between 0.22 and 0.29. So yes, there is convincing evidence that the teens are going to say yes more than the adults, just due to the fact that 90% of the time, the true proportion is going to be in between 22 and 29% more teens say yes. Okay. So we're starting to interpret some things and do some pieces here. All right. So random. Back to 3 conditions. We've talked about these before. Conditions, conditions, conditions. 3 conditions. The first one is random. Random has to be done. So remember, it has to be a random designed experiment or study. Now, remember, this is back in chapter 4. So now we're getting to the point where we're starting to use some old ones. So they've got, an SRS is simple random sample works, but the design has to be good. Why does the design have to be good? Because it ensures an unbiased estimate. Remember, we're using these statistics as an estimate, so an unbiased estimate or stat So it's ensuring that p hat is not biased. We don't want to make p hat too low. We don't want to make p hat too high. So making sure it's random ensures that the unbiased, that it's an unbiased estimate or the statistic, whether we're using X bar or we're using p hat, is unbiased. So that's the key piece. All right. So normal for this one is going to be our n times p is greater than 10, and n times 1 minus p is greater than 10. That still pops up. That's from last chapter. We have to check that it's normal, so we ensure the margin of error is correct, because the critical value, and I'll talk about that here in a second, the critical value is correct. If we don't do that and we don't ensure that the margin of error is correct, we can either have too wide or too small of an area, which puts our true proportion in a weird spot. So that's why we do normal. We're ensuring that our margin of error is correct. Now our independent, which is our 10% rule, it's our 10% rule, that ensures the correct formula. Correct formula for standard deviation is being used. So in other words, we want to make sure that the standard deviation is correct. And if you have too much of the population, it may be too big of a standard deviation or too small of a standard deviation. So we have to make sure that it's correct. So now when it comes to the formula for these, there is not the exact formula. So the exact formula on the formula sheet looks like this: point estimate plus or minus critical value times the standard deviation. That's the formula they give you. Now, for this particular one, we have to plug it in. So we're going to get p hat. So this is what's on the formula sheet. Then we have to add or subtract our critical value times our standard deviation. And well, if we fulfill our 10% rule, then we can get the square root of p times 1 minus p all over the square root of n. So that is, and this is on the formula sheet. This is on the formula sheet. So this is coming from a table, and I'll show you how to do that here. So this is going to come from the table, which is going to be the Z table, or what we're going to learn as a T table. There's two different ones. So this critical value is the new thing that we've got to learn from. So the formula sheet has this basic idea here for you guys, and they set it up so it doesn't matter what kind of confidence interval you guys are using, but it sets it up for you, and then you just use the formula sheet to fill in the rest of it. So technically it's not on the formula sheet, but it really is, because all the pieces are there. You just got to learn which ones to use. All right, guys, we'll talk to you later.